It's my pleasure to be here today and to introduce quantum computing and make the connection with AI, and especially AI for good. Pasqal was founded in 2019, following the meeting of 5 scientists who share the same bold visions based on the conviction: industrial and commercial pragmatism to enable practical applications of quantum computing. Quantum computing is a major technological breakthrough. Don't think it's a continuous improvement of classical computing means. It's really a description. We call it the second revolution of computing. And tomorrow, quantum computing will enable more computing power with reduced energy consumption. Please remember that. This is the main takeaway of the message: reduced energy consumption. And this will allow us to solve complex problems while tackling climate change. Maybe I would say it's a bit awkward.
Thank you so much. So we are going to open the floor to questions. So if you do have a question later on, raise your hand. So firstly, Georges-Olivier, I want to ask you, can you tell us what quantum computing is in a short sentence?
I think the question tells all. It's a computer. So we do computing. The difference is that we leverage the law of quantum physics to implement super efficient quantum computing tasks. The example I can give, today there are some tasks that are untractable on classical solutions, on classical CPUs and GPUs. When I mean untractable, it means that it will take billions of years to be computed. And with a quantum computer, you can reduce this billion of years to a couple of days. That's the potential which is behind quantum computing.
Okay, thanks for that. I want to start with, the kind of being said as the supercomputers. They're going to use a lot of energy. What are you doing at Pasqal to combat that and to meet the SDGs for, saving the climate?
That's I think, the key question. And the quantum computers, I think, can help 2 times in this challenge. So first of all, by the applications. Sorry, I'm just trying to manage the button at the same time. And quantum computing will transform many sectors: the energy, the defense, the aerospace, and more. And we have already use cases for energy, how to optimize the infrastructure, the electrical grid to make it smarter, how to charge a fleet of electrical vehicles, because that will be a challenge in the future. And by doing so, you will also reduce the energy consumption, because you will improve infrastructure, you will make them more efficient. So it means at the end of the day, less energy. I talked about the reduced computing time. This is also a way of reducing the energy cost. You can, with the quantum computers, we will be able to devise new materials, for example, for batteries, to make them more efficient. So everything is directed on reducing the carbon footprint. And the cherry on the cake is that the quantum computer by itself is very low energy intensive. Our computers consume the equivalent of 5 hair dryers. I mean, it's nothing in terms of electricity. And this makes a huge difference, compared to current today supercomputers. We will not replace them, but we will complement.
Okay, that's really amazing. And what do you, so talking about the benefits, it can, really solve algorithms that regular computers can't. So that's wonderful. And, tackling green and climate questions itself, how's the technology being used? What industries is Pasqal being used in?
Well, Pasqal is the hardware vendor, so we are building the tool. And now you ask me the question about the usage. Why should we use these quantum computers for? And I think it's important to use them for wise reason. Even though they are low energy intensive, if we use them for something useless, at the end we lost. So to this regard, last year, Pasqal organized an hackathon, a competition to program quantum computers. And the ideas here was that the participants were to develop the use cases by themselves, and we tasked them to develop these use cases and find one with direct impact on the climate change, and to address the SDG goals. That was the mandate we gave them, and they were evaluated on that. And first of all, I'd like to say that we had a very high participation. Almost 800 students all over the world participated to this hackathon, meaning that there is a real need. People feel concerned about this point. And the second thing is that the use cases were just amazing, I think. The first one was about weather forecasting or identification of new molecules for medical treatments, and also optimization of a wind farm and better prediction of production of wind farm to incorporate them into the electrical grids.
Okay, that's a really great use case. What other SDGs do you see quantum helping and doing good?
Well, the first one is drug discovery, I think. I will take this example. And the good news is that we already have use cases. I can highlight two of them. The first one is about computing the hydration of a pocket of a protein. And this is instrumental if you want to predict the reactivity of this docking site. And we can do that with a quantum computer. So it's a part of a full, a pipeline of steps of the computing steps, but this is the one that a quantum computer can increase. And we also develop machine learning techniques to predict the toxicity of new molecular compounds. So instead of running in vivo test, you can simulate them and get a faster response.
Wow, that's really fascinating. And what are you personally most excited about when it comes to quantum and how it can help the planet? What are you personally most excited about?
Sorry, I didn't.
What are you personally most excited about? The quantum.
Well, I think the energy consumption. For me, personally, it was a real trigger when creating the company. It's always great to develop new tools to help solving pressing problems. But at the end, you have to be sure that your new tool will be used wisely and will also participate to this journey. And the example I love giving all the time is that each request to ChatGPT in terms of energy is the equivalent of making a glass of water boiling. So each time you're asking a request to ChatGPT, think of that. You are preparing a cup of tea for each single request. And the fact that the quantum computers by nature is so energy efficient, was a kind of guarantee that the solution will participate, whatever.
Yeah, well, that's great. Technology that's not destroying the planet too much. So I want to ask you, what are the challenges in working in the quantum space?
Well, I think they are technical. The particles, the quantum particles that we use for the computing, we call them qubits. They are highly sensitive to the environment. So it's very hard, to protect their quantum behavior, and especially when you add more and more particles. And you need that because the more particles, the more qubits you have, the more powerful your quantum computer is. So controlling this state is challenging, but the good news is that there is no, there is no limitations. On the paper, there is no fundamental limitations. And here I would like to quote one of my co-founders, Alain Aspect, who was awarded the Nobel Prize in Physics in 2022. And he said that when there is no fundamental limitation, engineers find a path. So we are engineers, and we will find a path. And the challenge is really about making this new technology a reality. And the good news is that it's happening. They do exist, this quantum computer. We have them on our premises. They are currently implementing use cases, and real use cases, not toy models. We implement them at scales with customers. We are now even shipping them to data centers, to be installed on-prem. And I think we have already more than 50 customers all over the planet. So, it's not talking about science fictions, but a reality that comes true.
Yeah, because of course AI is using a lot of data centers which consume a lot of energy, so that's really transformative, I imagine.
Yeah.
Okay. Any questions from the audience that you would like to ask? The microphone will be ready, so do raise your hands. In the meantime, I want to ask you, we are in the age of AI, there's so much hype. Should we be spending more attention to quantum?
Oh, definitely, because people tend to forget that AI needs the hardware to implement the and to train the models. So we need both. I think that the solution which is used today, to meet the demand of computational power by AIs consists in piling up GPUs and CPUs always more and more. So we are building these kind of monsters, this super computing power, and at the end there will be a limit. This is not a sustainable model. And if we want to think about AI 2.0, we need to think about quantum. That's the first thing. And quantum computing will add a new pillar to AI, I think. A new pillar that will help AI entering in a more sustainable program.
Okay, I think we have one question.
Yeah, hi. I'll have mine of the One Goal Initiative for Governance. I wanted to ask you, if somebody, a random person, say me, I want to learn about quantum technology a bit like an engineer would, in depth, where do I get that education?
It's a good question, and the first part of the answer is that you don't need to understand quantum physics to use a quantum computer. If it were the case, I would have missed something as a company. So at Pasqal, we are providing all the tools, all the software stack that allows you to have access to the computer in a completely quantum agnostic way. So this stack is open source, so if you want to dig in, you can. You can really control the particles at the physics levels, but this is not mandatory. So as of now, what we offer is this full stack solutions. It's open source, it's free. You can have access to our GitHub page and download our programming environment. You can also use a very simple graphical interface on the web. It's for free, and again, you don't need to have this background in physics. Back to my hackathon, the 800 participants, they were mostly data scientists. And today, a classical data scientist can use our technology, and our tools comes with, with tutorials, with examples, so you can learn. And as for me, I was very impressed by how fast the competitors learned this new tool. It was really amazing.
Any other questions? Yes?
Can you hear? Yeah, perfect. Thanks so much for the speech. When do you predict the ChatGPT moment for quantum?
Oh, thank you for the question. I think today quantum computers, as I said, are tackling the first industrial use cases, and we are, for the first time ever, we are matching the performances of classical computers. First time ever, this is the first step. We do that using less energy, by the way, and now rich from this experience, from this real-world implementation, and for, let's say, our deep knowledge about the quantum computers, we can predict, we can foresee that the first use case in production could happen in 2 or 3 years. And this is tomorrow, because, following your question, you need to learn, you need to train the team, you need to understand what the quantum computer is good for and how you can use it in your pipelines. And this takes time. So start your quantum journey now, and in 2 years, you will be ready to benefit from the ROI of having a quantum solution into production.
Okay, we have another question.
Do you hear me? Yes.
Yes, but I cannot see you, and it's a bit
how do you predict how will security policy will change with wide adoption of quantum computing? I mean, for companies, for users, for blockchain, for crypto, because it will solve many crypto enigmas very quickly. So how would we must adopt our security policy right now?
You are referring to the capacities of a quantum computer to break cryptography?
Yes.
Okay. So indeed, this is a threat. Because if you want to break cryptography, at some point you will face a hard computational task, which is about finding the prime number of a large number. And for a classical computer, this is intractable. And since it is intractable, cryptography is said to be safe. And a quantum computer can be seen as a threat because it can implement this mathematical operation super efficiently and super rapidly. So there are two parts of this answer. So first of all, the quantum computers that will be able to implement and to break cryptography at scale does not exist yet. And I think it will not exist before decades. And this doesn't mean that there are other use cases that we can address with the existing technology. But for this one in particular, it will take time. And second, the quantum physics is the threat, but is also the solution. Today, there are solutions that can prevent you against. You can develop telecommunication means that are resilient against the attack of a quantum computer, and you can also develop new cryptography that are resilient against the attack of a quantum computer. And it's just, I'm not a user of cryptography, so it's just a matter of changing the way you are coding. You still have time. I know that sometimes the lifetime of sensitive data can be very long, so it's better to anticipate. And I think that now the regulation standards are considering this problem, and it's moving.
The EU's definitely working on that. And just to reassure you, I've spoken to cryptographers who are also working on this, so I don't think we're too worried. There's it's being worked on. Okay, unfortunately, we are out of time. Please, I want to thank Georges-Olivier for that really fascinating discussion there on quantum.
Thank you.